chugging this. You must be out of your mind. What is? No. That one's enough. One's enough, sir. Thank you. No more. Thank you. I don't think I can take that. Oh my God. That is horrible. Alrighty. I think we're just gonna wait one more minute and then we'll get started. For the people in the back, there are seats here if you want. A lot of them. Alrighty. Alrighty, I think we're going to get started. So, welcome everybody. We're going to be talking about DeathStar. DeathStar is a Python script that I've written that basically automates the process of getting you from a domain user to a domain admin in 90% of like your run-of-the-mill Active Directory environments. We're going to be taking a technical deep dive into the misconfigurations and vulnerabilities the Python script exploits or abuses to do this. This is not necessarily going to be like just a full-out tool talk. I'm not going to just sit here and talk about this 200-line Python script that just makes some RESTful API calls. But we're going to be taking a fairly deep dive into the vulnerabilities themselves and the mitigations, and we're going to go from there. So the Who Am I slide. I'm from Coalfire. I work for Coalfire Labs. They're kind enough to sponsor my trip to conferences and to make me work on these projects in my free time. I go by ByteLeader. That's the link to my GitHub repo and my blog. I have other projects as well, which I've talked about in the past. Before I begin, I just want to take the opportunity, since this is a tool that somewhat automates the process of Active Directory pen testing, so I want to take the opportunity for a mini rant time. I hear this a lot from pen testers, unfortunately, and consultants a little bit everywhere, and it drives me insane every time I hear it. It's sort of a pet peeve of mine. But domain admin isn't really the end goal of a pen test, especially if you're just a security best practice pen test. Like, you should be focusing on post-exploitation more than actually getting domain admin. I cannot count the number of times where I've read just reports from a little bit of everywhere, and they just completely stopped at getting domain admin access. If you present that report to an executive and you just give them a report that says, here, I got domain admin, that's it, they're just going to not understand the impact that has overall. On the other hand, if you present them with a report that has credit card data, PII, anything, the crown jewels of the network, the impact will be obvious to them, and they will actually take steps in remediating those vulnerabilities, as opposed to just saying to the blue team, here, I don't know what this is, go fix it, please. So it would be much more impactful if you do that. And this is especially important in this day and age, really, when it comes to pen testing, because more and more there are tools that just automate the complete process when it comes to pen testing or just finding the vulnerabilities themselves in Active Directory. So just don't be lazy when it comes to pen tests. Like, just do your job, and I think that'll just make everyone better and safer. So one more thing before we begin is that this is not also going to be like, we're not going to be talking about advanced red team tradecraft here. This is if you saw like the talk yesterday from the Spectre Ops guys about ACLs and backdoors, or just getting that domain admin access through ACL misconfigurations, this is not going to be about that. This is just going to be the average run-of-the-mill Active Directory misconfigurations that I personally see in every environment. And that's what DeathStar does. It uses those average run-of-the-mill Active Directory misconfigurations to actually give you domain admin access. So what is it? It's a Python script. It's written in Python 3, open source. The link to it is at the bottom of the slide. But it basically just uses Empire's RESTful API, to be exact, to automate getting you domain admin. And like I said before, I'm reiterating this, but this is this is not something that's really advanced. Like the techniques here are just something, the usual things that you do with PowerView or Mimikatz, for example. They're just completely automated, and it's similar to what we've seen in a while with some malware, which we'll get into a bit. Why do we even need this? Well, the reason should be pretty obvious, but let's just, I'm guessing, like show of hands, how many of you here pentest Active Directory on a regular basis? Okay, that's what I expected. So if you're probably already thinking like, well, if you just look at what I do on a regular basis and see that this is pretty repetitive. Like, usually what happens, you acquire foothold by using some means. Situational awareness, so you use PowerView, Bloodhound, whatever you prefer, or just do it through built-in command line utilities. You perform some kind of domain prevesc. Usually it involves like Kerberos or finding group policy preference passwords in those XML files, which is what DeathStar does, which we'll get into in a bit. EDUMP credentials using Mimikatz, the SAM database. Perform lateral movement using some technique, WMI, the COM stuff that's come out recently. Whatever you prefer, and then you just repeat the process over and over and over again until you get domain admin, or just maybe even not, you just find the data you're looking for and exfiltrate. So this is a really manual task, and each time I just find myself doing the same thing over and over again. And quite frankly, the clients that I usually get don't have the security maturity to even to me attempt like advanced red team tradecraft, like the ACL stuff that I talked about. So this is just basically trying to automate those regular tasks that I do on a regular basis. So getting a foothold. We're gonna go over this real quick, just for in case maybe you haven't heard of some of these tools. But this is the only thing that DeathStar really won't do for you, for obvious reasons, because it really depends where you are. So if you're externally, if you're trying to get a foothold on an internal network externally, there are a couple of ways. Ruler and Link Sniper are my go-to. Usually people have Exchange servers or Skype for Business link servers available externally. Shout out to the SensePost guys for Ruler because it's freaking amazing. It basically abuses Outlook rules and more recently forms to give you that internal shell. I won't go into detail on any of these tools because that could be a talk of its own. Link Sniper, same thing as Ruler basically, only that it takes advantage of Skype for Business servers hosted online. It allows you for brute forcing against link servers, Skype for Business servers, and it gives you access to, and if you find a valid set of credentials, you can just gain access to someone's Skype, and you can perform like really neat social engineering attacks, or gain access to the global catalog, which is sometimes very useful. If you're already on the internal network and you need to get the first foothold in a Windows environment, you can use Responder, InPacket, CrapMyZec. Responder, InPacket, I mean, if you're not using those, you're probably doing it wrong, but Responder, takes advantage of those multicast broadcast protocols. InPacket, same thing. Well, not the same thing, but it's a library that that basically incorporates a lot of the Windows API calls, so that you can, and it has a set of example scripts that are awesome that you can use to perform lateral movement, dump the SAM database. There are a bunch of, and it's completely written in Python, so it's awesome. CrapMyZec is another project of mine that basically just automates performing post-exploitation tasks, and it helps with getting that initial shell on Windows on large Active Directory domains. So there are options of getting that initial foothold. So I'm going to gloss over this because, quite frankly, we probably are nauseated every time someone mentions this, because we see this on almost every environment. But multicast broadcast name resolution poisoning. So LMNR, MBNS, WPAD are the major ones. There are others, like MDNS. I personally have never seen those in a live environment yet. If any of you have seen any other protocols, broadcast protocols other than this, let me know, because I'm really interested in seeing that. This basically just straight out allows you to grab authentication hashes off the network. And this is probably one of the culprits when it comes to this. That little checkbox there, the checkbox of doom, I call it, is probably the evilest thing I've ever seen on the Windows operating system. But that basically tells Internet Explorer to go look for that wpad.dat file, that pack file, to download that proxy auto configuration file, which you can then poison. So how do you mitigate this? Because I like talking about mitigation too in my slides, because otherwise I feel weird if I don't talk about mitigation. So create a WPAD entry that points to the corporate server proxy or disable proxy auto detection in Internet Explorer. Disable MBNS LMNR. LMNR can be disabled via group policy. MBNS is a little bit trickier because it depends on your domain functioning level. You can't, if your domain is at a certain domain functioning level, you can't really disable MBNS, and also older operating systems might rely on MBNS itself. But you can disable MBNS, I believe, via DHCP, which I personally, other people have suggested. There's like PowerShell scripts out there that allow you to disable it, but I've personally always disabled it via DHCP. Always, all these changes that I'm going to be mentioning through going through these slides, please test in the lab before deploying in production, because all this stuff can break legacy systems. You're going to want to set valid DNS entries for all internal and external resources, and monitor network traffic for broadcast poisoning attacks. If you're familiar with Responder, if you looked at the code that Responder has, you can see that the packets that it generates can be pretty easily signatured. So that's a pro tip in case you want to actually write rules and stuff for IDSs to detect Responder network traffic. Difficulty moderate, break stuff maybe. Like this takes some effort, and it can break stuff. It can break legacy systems. It can break custom applications that rely on LMNR to discover hosts on the network. SMB signing. This is something that, in my opinion, is the one of the most overlooked and underrated security settings in a domain. I see a lot of, like, if you just Google like top 10 security checklists for Active Directory, normally they don't mention SMB signing. SMB signing is somewhat like forgotten for some reason, but I'm really trying to, every time I talk, I really try to mention SMB signing because it's just such a critical security control. So SMB signing basically digitally signs each connection so that the server is completely sure that the connection originated from the actual host as opposed to a man in the middle. And you're going to want to enable this everywhere, which we'll talk about in a second. But you do this by setting the proper registry key. You can do this via group policy. Again, test the lab before deploying in all systems. It's pretty easy to do, but the problem is that there could be additional overhead on the servers that require SMB signing. And also it might break stuff like legacy applications and operating systems that do not support the security setting. So the reason why I mentioned SMB signing in Responder is because this is probably the easiest way to gain a foothold in an internal environment. NTLM relaying. This is something, again, that I'm trying to sort of push because every time I talk to people, there seems to be a lot of confusion about NTLM relaying. But you can actually, with the hashes that you get with Responder, you can actually relay those to other machines on the network if there's multicast broadcast protocols in play and the hosts do not support SMB signing. So you can basically just use Responder, NTLM relayx.py, which is a Python script that comes with the in-packet library, and Empire. And you can just set NTLM relayx.py to execute a command on every successful relay, and you just get shells on each machine. Usually I just set this up, grab a coffee or orange juice, come back, and I have a foothold in the network. This can be a complete talk of its own. I thought I'd just mention this again because there's a lot of confusion around this attack, but I actually wrote a blog post about this that shows you some practical operational examples in the link down there, and just tries to demystify this attack a little bit better. So, situational awareness. This is where DeathStar comes into play, and it also automates. This is the part where this DeathStar starts automating a lot of things. So, situational awareness. PowerView is the go-to when it comes to situational awareness. GetNet group member, GetNet local group, invoke user hunter. These are all the utilities that you can use to gain that situational awareness. So, enumerate domain admins, enumerate local groups, see where the domain admins are logged in. You're going to want to also enumerate domain controllers. This also seems to be there's a lot of confusion when it comes to this. A lot of pen testers and consultants that I've talked to tend to actually target domain controllers as opposed to stay away from. I don't understand why, because if you send an exploit to a domain controller like MS17010 and it brings down the domain controller, not only you might crash the entire network, but it's also the domain controllers are the servers that are usually the most heavily logged. So it's just, I find it really bad form when someone actually tries to target domain controllers as opposed to staying away from them. The only reason why you want to go after domain controllers is to perform DC sync attacks or just dump the NTDS that did. Other than that, I think you should probably stay away from it. So mitigation. Situational awareness is a little bit difficult because a lot of the features that we're using to gain this information are a feature, not a bug in Microsoft eyes, mostly because of backwards compatibility. There are some TechNet PowerShell scripts that I don't think a lot of people have heard about, but Itai Gradi, I'm hoping I'm pronouncing his name right, but he wrote a couple PowerShell scripts. He's from the Microsoft ATA team that basically harden Windows operating systems and cut down on the amount of information that you can get via session enumeration and SAMR enumeration. So this will, I haven't tested this, but it should, in theory, cut down a lot of the information that like Bloodhound gets, for example, or Empire itself through Invoke User Hunter or PowerView that you can normally get. If anyone has any pro tips on cutting down information gathering on Active Directory, please let me know. On the cheap, preferably, because I don't believe in flashy blinky boxes. I preferably want something like, you know, in that Microsoft provides, so even if it's the third-party Microsoft tool, but I do not believe in flashy blinky boxes. So if you have something on the cheap that cuts down on this information that an attacker can gather, let me know. Difficulty hard, because it's pretty hard to cut down on this information, and it could break stuff if you do try to mess around with maybe like Active Directory objects, permissions, and maybe to try to cut down the information that people can gather there. It can break stuff. So that's just something to keep in mind. Domain privilege escalation. Domain privilege escalation usually comes in the form of Kerberoasting or just group policy preference files and group policy preferences. DeathStar just tries to use the old-fashioned group policy preferences, passwords and group policy preference vulnerability. So, quick summary of this is that basically in every XML file in the sysvol share, well, in every group policy preference, when you create a group policy object that has a username and password in it, the username and password gets stored in the sysvol share in an XML file, and in the cpassword attribute, and that password gets encrypted with AES-256. Problem is, in early 2012, a little bit earlier than that, basically Microsoft released the shared secret for that encrypted string. So anyone that basically can access the sysvol share can just decrypt that entry now. So this is great because every time administrators push out local accounts via group policy, usually that you'll find the XML share in the sysvol, in an XML file in the sysvol share, and you can just decrypt it, which is awesome. And we can leverage that to move laterally or even just escalate privileges in a domain. Mitigation to this is to install the patch and delete existing group policy preference XML files in the sysvol share. And just don't put passwords in files that everyone can access. That's just a general rule of thumb, I guess. This can be easy moderate depending on how your report is written, because unfortunately, it's not enough to just apply the patch. You have to actually go into the sysvol share and manually delete the XML files. And unfortunately, a lot of people, when I see reports, a lot of people don't actually put the full path to the XML file in the sysvol share. So when the blue team or system administrators try to actually go back and delete them, they have to manually do it. And sometimes if they manually have to find those XML files, they just don't do it for some reason. That's just something to keep in mind. And usually that doesn't break stuff, so that's good. Dumping credentials, Mimikatz. We all dump credentials in one way or another. Windows stores domain credentials in memory, specifically in the LSASS process, and we could just dump those credentials via Mimikatz or another tool, whichever you prefer. PowerSploit comes with a handy-dandy invoke Mimikatz feature, invoke Mimikatz script that you can use to directly inject Mimikatz in memory and dump credentials through there. Mitigation. Well, you can't perform this attack on Windows 2012 R2 Plus or Windows 8.1 Plus. You should install that patch for older systems and set that registry key everywhere. And you can actually monitor that registry key because there really is no reason for that registry key to change value other than even if it's not a malicious attack, really. So the attackers know about this trick. So if you change that registry key back to the value of 1, Windows will store passwords in memory again, even though you apply that patch. So that's just something to keep in mind. And also, your administrators should really have a separate workstation for their administrative activities, as opposed to having the same machine for going to Facebook and performing the administrator activities as well. So this is pretty easy to mitigate. And it might break stuff depending if you have applications that require accessing the LSASS process space. Lateral movement. Local administrator accounts. Don't do that. That's actually a screenshot from a live client environment where they just made everyone local administrator. It's awesome. Development, local administrator, domain admins, domain users, why not? IMP, infotech, man, admin, yeah, everyone's local administrator, why not? It's awesome. That was a really quick pen test. So everyone here gets domain admin. It's great, and you just go around the network and pop boxes. It was awesome. Mitigation, Microsoft Labs. It's free. It's awesome. It works. Just remember to configure it correctly, because if you don't, everyone can just access every password on every machine because it stores the password in Active Directory objects. So if you misconfigure it and make it readable, everyone can just access those passwords. So we have all of these attack primitives and just all of these misconfigurations that we see in every environment. And the goal here is just to automate everything and to make it as easy as possible to get that domain admin access. So initially, when I was thinking about how to actually automate this whole process, I was thinking of just writing something from scratch. But then I just got thinking and I said, well, Empire, it's awesome, and it has all of these modules that basically by themselves do everything that I want this script to do. So we have the situational awareness modules, the get group member, get domain controller, user hunter, find local admin access, get GPO computer, get logged on. These are the primitives that we need to acquire all the information to automate this entire process. This is all the information that we need to find where the domain admins are logged on, who domain admins actually are, where the domain controller is at, find local admin access. So for example, if we inject into a process, we can then use that security context to see if that user has other boxes it can access. Get GPO computer, so we can resolve the GUIDs of the group policy objects that we pull down from the sysvol share, which we'll get into a bit. Get logged on to see who's logged on, and et cetera, et cetera. And again, these are just all of this functionality was already built in Empire. So when I was initially trying to come up with a way to actually automate this whole thing, Empire was just a choice. And thankfully, it has a RESTful API, so we can automate the entire process. So this is the flow graph of how DeathStar actually works, and I apologize if this is slow, if this is small, but I'll be posting the slides online, so if you want to look at it later, you can do that. So basically, at the start, DeathStar checks the Empire credential database to see if we actually have the domain admin credentials in the database. We then see if we have any agents that are currently running that are using the domain admin context. If there are no agents, it checks to see if there is a new agent. And if there is, it will basically start gathering information on the domain. So where the DC is at, where my domain admin's at. So get net domain controller for the domain controllers, get net group member to gather that list of domain admin members. This has actually changed recently because there are other languages except English. The way it does it now is it resolves the domain SID and just appends 512 to it so that it will just get the domain admins group members without relying on the actual name called domain admins. Oops. Well, that's unfortunate, but not really unfortunate. Kind of happy that happened actually. All right, invoke user hunter. Invoke user hunter again. It finds those domain admins, which is awesome. It does everything automatically. And it adds the host and session from fields of the output to the priority targets. And this is a way of just prioritizing those boxes where the domain admins are actually logged onto, which we can then try to compromise with once we gather further information on the domain or we start moving laterally. So once we have that situational awareness initially, we then use the get net logged on function to see if anyone is logged in locally or remotely, and if so, any of the domain admins are logged on locally or remotely, and if so, we add those to the priority targets. We then try to attempt domain privilege escalation. Again, I'm not even trying to curb roast, like this is just plain old group policy preferences, the passwords and group policy preference XML files, so we use the get GPP password module in Empire. We then parse the GUID of that group policy object to resolve through GPO correlation which computers that GPO is applied to. And then we use invoke WMI, and this is where the lateral movement starts. So we start spreading out through a network using that local administrator account that we decrypted from that XML file. We then start seeing if any of the agents that returned, that we got back from the lateral movement and any other techniques that we run are running in a high integrity context. So that means we're local administrator on the machine. If we are local administrator on the machine, we start enumerating the running processes. And if there are any processes that are running on different users, we inject into those processes using PS inject. And this is just a really handy way to basically inject into a process and start using that the user's security context to see if that user has local admin access on other machines. If the operating system is Windows 10, we just run Mimikatz to see if there are any interesting credentials in memory. And then, since it's not necessarily all users are going to be logged into all machines, any of the credentials that we get from Mimikatz, we spawn additional agents on some of the machines that we already compromised to use their credentials and again start moving laterally to see if we can compromise any additional machines. So this is basically what it essentially is trying to emulate is a worm. So it just tries to straight up compromise the entire domain until it eventually finds a computer with a domain admin logged into it. And of course, from the output that we got from Invoke User Hunter, it does prioritize those machines first. So in case we do have a domain admin that's actually logged in, it will try to compromise those boxes first as opposed to the entire domain, and then it will stop. If we don't have if you don't have an agent that is running under high integrity context, it will then just attempt to elevate using a UAC bypass. So in this case, DeathStar currently just uses the bypass event viewer module, which is a UAC bypass discovered by Matt Nelson, which uses the event viewer, and it's completely fileless. It just sets a registry key, if I recall correctly, which is awesome. So that's basically how it works. Demo time. So I was going to do a live demo, but then at the last moment I thought that would probably not be a good idea. So I have videos. So these are on YouTube. In case, no, I do not want to play back where I left off. Thank you very much. Okay, perfect. So in case it is too small, they're on YouTube. And you could just type DeathStar. It should be like the third or fourth thing that comes up. But what we're doing here is we're first generating a launcher with Empire. We're going on our machine, on our Windows machine here. We're just verifying that we're running under a domain user. So we're running under a domain user currently. We're pasting in our PowerShell launcher so that we get an initial agent for DeathStar to do its thing. Initial agent called back, so now we have a foothold in the environment. So now we go over to DeathStar and we fire up the Python script. So the first line of output here is it finds the new agent connected, and it starts performing situational awareness. So it found the two members of the domain admins group. In this case, administrator and God, two accounts that were part of the domain admins group. Found the two domain controllers. And now it's going to start performing user hunting to find where those domain admins are logged into. So there are 4 local admins. There are 4 active admin sessions. Found 1 user logged into localhost, and what it's now going to do, it's going to start lateral movement and the domain privilege escalation, and it's going to attempt to elevate to a high integrity context using the event viewer bypass that we talked about before. It connected, it executed the get GPP password module, and now it's going to parse those credentials and resolve the GUIDs of that group policy object to those computers, and from the output here it sees that it's applied to 6 computers, and then it starts moving laterally throughout the domain. So you can see here from the output there's a new agent that's being connected, And we see that we just keep getting agents in Empire. So this is just Empire automatically performing lateral movement throughout the domain. So it basically compromised all the machines in the lab environment at this point, and it found that there's a domain admin logged into one of the machines that it, from one of the agents that it compromised. It's enumerating the local processes and it's PS injecting into all the processes, and it's continuing to perform lateral movement. And this can take a while. It can take as long as Bloodhound, basically, essentially because it's performing the same operations that, almost the same operations that Bloodhound does, only on a slightly smaller scale. And there we go. So we've gotten domain admin by basically PS injecting into a process that has the same context, as a domain admin, and at that point it just shuts down, and from the rest of the video you can see that we have an agent running as domain admin. And just to prove that I'm not lying to you, I guess I decide to interact with it and just do a who am I. Perfect. So I don't know if you can see that, but basically we're running on the domain admin context. So that was just gaining domain admin without using Mimikatz. So that was just by abusing local admin relationships. If we add Mimikatz into the mix, it becomes a whole different story, which is another video that I have here real quick. So again, we generate the PowerShell launcher. I'm just going to skip ahead here. Paste the PowerShell launcher. There we go. We have the initial agent. Run DeathStar, and this time, instead of only abusing local admin relationships, we are going to be using Mimikatz as well as dump credentials, and it's going to be spawning additional agents using those dump credentials. Performing recon, it's the same environment, so I'm just going to move here, and also I think we're a little bit, well, we're doing good on time. So it's already starting to spread laterally. It's PS injecting into the processes that are running under different users. And it's executing Mimikatz as well in the background. So this time it's spawning additional agents using those dump credentials. At this point, it found a logged in domain admin. It's going to dump those credentials from memory. And you can see here that it got domain admin via credentials this time as opposed to just via the security context. So you can see here it has on the screen, it's a username and password, and it has the domain admin credentials. So we can see this is entirely possible to automate the whole process really in 90% of your average Active Directory environments going from domain user to domain admin. So if you're familiar with a lot of the events that happened recently, this should sort of sound familiar to you. A program that automates lateral movement, it uses some of the lateral movement functionality to infect an entire Active Directory domain. It was sort of a coincidence that I wrote this blog post in 29th of May, and I did make a point in the blog post that it'd be interesting because this is like a 200-line Python script. It's nothing fancy really. And I said that it would be interesting to see, because if I can do this, I wonder what nation states could do. Like, it's entirely possible that nation states would have this capability, if not something much more sophisticated. Well, just so happens, 3 weeks later, NotPetya is a thing, and it basically uses the same concept where it dumps credentials, starts moving laterally automatically throughout an entire Active Directory environment, only that in this case it actually just completely wipes computers instead of just dumping credentials, which is sort of not what we want to do. Another thing I like to point out is that I'm not the only one that thought of this, obviously. This is basically, it's the same concept, only using a different implementation. Tal Moore from the ATA Microsoft group, he's an awesome guy. I met him at Black Hat this year. And he basically wrote GoFetch. GoFetch is the same thing, the DeathStar is basically the same thing, only that it uses Bloodhound instead of Empire. And it automates the entire process of, again, going from that domain user to domain admin. It uses PSExec for lateral movement, if I recall correctly, instead of WMI, so it's a little bit less stealthier. But it is the same concept, really. And finally, these are people you should probably follow. They're all awesome. They're really pushing the industry forward. These are the guys that are really driving the Active Directory industry at this point. So you should all follow them. Questions? I think that's it. Sure. No, that's just it attempts to decrypt those passwords in sysvol, but if there aren't those XML files, it could just get domain admin via a lateral movement, so like in local admin relationships or just credentials, really.